Oh, I went to a new video. Whoops. Oh well. Can't imagine how the OR gates and stuff like that are going to be. We want to switch und a light. And just for posterity's sake, I will super glue them to the floor. Alright, so this is how it's going to work. This is our input, the switch. This is our output, the light. So we want our input to go to our input of the logic gate. Almost always pistons, the gadgets that you use will be the inputs. So in this case, our input is the piston, because when the button is pressed down here, we want the thing inside of the box to move, which would be the piston. Our output is the magnetic key. That will always be your output, almost, unless you have some funky design. Here we go. I'm going to pause. Okay, sorry about that. So, now we've got that and that. Now then, we need to switch our input. We can't have it on-off, because if we have it on-off, when we press the thing, this will go back and forth, like, really fast, all the way back through the shaft, all the way forward through the shaft, really fast. And if you have it at 0.1 timing, that can sometimes break your blocks, if the block is impacting with the side of the container. So we need this to switch to direction. So now when we press it, depending on how we press it, this will shoot forward and stay forward, and then when we jump off, it'll come back, or however we do it, however you want it. So let me get off. So right now, can you see the problem? It's right now the switch is false. So, since it's a NOT gate, it should be a true outputting, and the light should be on. See? Then we hit that, it slides forward, and it does that. And the box is actually impacting with the side, but that's okay. So, what we didn't do in this case is flip it. You want it to be a backwards motion. So now it's constantly being pushed forward. And this is where you can go into like really like high grade fine tuning. You zoom in here, go up to your maximum length and start pulling it back. See, so now it's not impacting with the side. I'll put it right there. It's still within range. And now, actually, I can probably, I don't know if I can actually, because I don't know if I tuned it enough. I can probably get away with a 0.1. See how fast that's moving now? So now it's almost an instantaneous reaction. And that's actually really helpful when you make really big projects, that you have that 0.1 second resolution, because then everything just moves so smoothly and so fast. But see? Input 1, output 0. Input 0, output 1. That's the basic mechanics behind a NOT gate. Alright, and then I'll show you the other way of... Actually, no. In the next video, we'll be making... Oh, let's just do an OR gate. An OR gate's pretty easy. In the next video, we'll be doing an OR gate. And on the OR gate, I'm going to show you the different way of creating the box. The actual container. So, yeah, that's a NOT gate for you. Oh, and also I will be posting, I will eventually make a level where you can basically get all of the gates that I make in these videos. There'll be a different version because I have better versions. Like, I have more finely tuned versions in my objects, saved objects thing. But yeah, you'll be able to come in here, get whatever you want. They'll be adequately described and named so you know what the hell you're doing. There'll be multiple input AND gates, not just 2. I have one for 4. I plan on making one for 3, 8, and then 8 with 2 output. I don't know, like clusters of them. And yeah. So there you go. And I also plan on making a few microchips. That is going to be a bit complicated, but it'll be totally worth it because it'll be totally amazing. But yeah, there you go. A NOT gate. Woohoo, your first logic design in Little Big Planet. Soon you'll be off making your own version of Space Invaders and Galaga and Oblivion. I can't wait to see somebody make Oblivion for this with logic gates and combat systems and stuff like that. That will be amazing. Alright, so there you go.